Hello students! In this lesson, we will discuss about how to name aldehydes. So aldehydes is a functional group in organic chemistry, and we will also follow certain IUPAC rules in naming for the nomenclature of specific aldehyde compounds. But stay tuned till the end of this lesson as I'll be revealing the answer to this pretest. So, can you name these following aldehydes? Aldehyde is a functional group in organic chemistry that has a general formula of R-CHO, wherein the letter R represents the chain of hydrocarbons and aldehydes contains the suffix of Al. So aldehydes have a carbonyl group that is attached to a hydrogen. So if ever in organic chemistry you'll see a group that has this structure, then that's automatically an aldehyde. So let's have an example to show you what I mean. This specific aldehyde is called pentanol, and I have here both the graphical and the skeletal structure for this aldehyde. So it has the carbonyl group, so I'll show you. So this is the carbonyl. It's a carbon double bonded to an oxygen, and this carbonyl group is attached to a hydrogen. If ever you'll see these elements present in a functional group, then that is automatically an aldehyde. Naming aldehydes is no different than naming hydrocarbons with substituents. We still follow the same flow of first identifying the parent chain, identifying substituents or any alkyl group, then we combine them together with the formula of substituent plus parent chain equals to the aldehyde name. But in the case of aldehyde, we just simply have to change its suffix to Al. So, for example, we have the propanal. It ends in Al. Let's get into naming aldehydes with our first example. So, I have here both the graphical and the skeletal formula for an aldehyde. They're just the same aldehyde, but different graphical representation. And it's time for us to name this aldehyde. So first up, let's find the parent chain by counting the number of carbon atoms present. So in this case, we have 1, 2, and 3. So I have here a checklist, a step-by-step process to get to know our aldehyde. So first, the number of carbon atoms, that is 3. So our parent chain, it's a propane, as we can't see any double or triple bond. The second checklist, do we have a double or triple bond? No. Do we have any substituents? No. So therefore, we already have the name of our first aldehyde. Since this is the parent chain is a propane, then we just simply have to change its suffix to Al. So this specific aldehyde is a propanal. Let's have another example to complicate things a bit. Let's add more spices and challenge. So I have here another example of an aldehyde with both the graphical and skeletal formula. So the first step is to identify our parent chain. So in this case, we have 1, 2, 3, 4, 5, and 6 carbon atoms. So can we see any carbon-to-carbon double bonds? No. So in this case, we assume that we have an alkane with 6 carbons. So that's a hexane. How about our third checklist? Do we have any substituent? Yes, there is. And as we can see, it's a methyl group located on our 4th carbon. So our substituent is 4-methyl. Now that we have our variables, let's add them. Substituents plus the parent chain, then change the suffix to Al, then we have our aldehyde name. So this aldehyde is named 4-methylhexanal. It's just easy, right? Let's try another one with more branches and complicated structures. So here is our last example for our aldehyde. So let's get on to the first step. First step, let's identify the parent chain. So as we can see, we have 1, 2, 3, 4, 5, 6, 7, 8 carbon-to-carbon parent chain. And that's the longest we can possibly have in this specific example. Now that we have the number of carbons, let's check onto the second checklist. Do we have double or triple bond? Yes. It's located on our 3rd carbon. So our double bond is on the 3rd carbon connected to another to the 4th carbon. And then lastly, our substituent. So let's check. We have a fifth ethyl and sixth methyl. So those are our two substituents. Now that we have all the variables that we need, it's now time to combine them. Substituents plus the parent chain, then that is the name of our aldehyde. So this specific aldehyde is called 5-ethyl-6-methyl-3-octenal. So take note, we have octenal. It's not octanal. Why? Because it's an alkene with a double bond. So we still use the suffix of alkene. So it's octenal, and we also locate or specify the location of the double bond, which is on the third carbon. So here we have our name for our aldehyde. Alright, students, so that's just how easy it is to name our aldehydes. Maybe the notable difference is we only change the suffix to al, such as octenal, pentanal, propanal. So that's the observable difference when it comes to aldehyde. Alright, so thank you for staying till the end of this lesson. I'll now reveal the answer to our pretest earlier. So the answer for our pretest, number 1, that is a 3-butanal, since this is an alkene and its double bond is located in the third carbon, and it has a total of 4 carbons. So that's a 3-butanal. And the second one, we have 4-ethyl 3-hexenal. So this time we have an alkyne with a triple bond on its third carbon and a substituent of ethyl on the fourth carbon. Alright? So thank you so much for listening to this lesson, and I hope you learned something to study for your organic chemistry lessons and quizzes. So again, I've attached in the description down below the PowerPoint presentation that I've used for this discussion. And if you do have any questions, kindly comment down below and I will respond to it, to your organic chemistry queries. All right? So thank you once again, and I'll catch you in the next one.